am Althea Kilarui from BSEM-3A, and for today's video, we're going to learn about the systems of linear equation. So first, let us define what is the systems of linear equation. So it says here that a system of equations is simply a set of two or more equations with the same variables. So we solve them together to find a common solution that satisfies all the equations. So let us have an example. If I say x plus y is equal to 10 and 2x minus y is equal to 4, so basically what we are looking for. So we are looking for the values of x and y. So we are looking for the values of x and y because we want to satisfy these two equations. We want to show that these two equations are true. So now, let us talk about the different solutions of a system. So we have three types of solutions. So the first one is the consistent independent, or exactly one solution. Second one is the consistent dependent, or has infinitely many solutions. So the last one is the inconsistent or no solutions. So I have here a graph. So we're going to identify what solutions are these. So consistent independent or exactly one solution. So when we graph this solution, the lines are intersecting. So which graph are intersecting? So basically this graph. So this graph is consistent, independent. So our second solution is consistent dependent or infinitely many solutions. So when we graph this solution, the line is in the same point. So in this case, the line that in the same point is this one. So this graph is consistent dependent. Then lastly, we have the inconsistent or no solution. So when we graph this solution, the lines are parallel and something like this. The lines are parallel and never meet or never cross. So this graph is inconsistent. So did you get it? So to solve a system, we have a different methods. So we have elimination method, substitution method, and graphing method. So let's go first in elimination method. So I have here an equations. So we're going to add these equations using elimination method. So elimination method, we're going to add or subtract equations by eliminating one variable. So the equation 1 is 4x plus y is equal to 6. Then the equation 2 is 2x minus 3y is equal to negative 4. So we're going to add these two equations. So to eliminate one variable, we're going to multiply this first equation to 3 so that we can eliminate the value of y. So we have 3 times equation 1 plus equation 2. So 3 times 4 is 12. So we have 12x. Then 3 times y is 3y. So we have 3y is equal to 3 times 6 is 18. Then the equation 2 is 2x minus 3y is equal to negative 4. So we're going to eliminate the value of y because positive 3y plus negative 3y is 0. So we're going to cancel this one. Then add this 12x plus 2x is equal to 14x is equal to 18 plus negative 4 is 14. So in this case, we have 14x is equal to 14. So we can get here the value of x by dividing both sides to 14. So we can divide this side. So 14, then 14. 14 divided by 14 is 1. So we're going to cancel. We have x only. Then 14 divided by 14 is 1. So now we have a value of x which is 1. So to get the value of y, we're going to substitute this value of x to the equation 1. So let x is equal to 1 to equation 1 to find y. So equation 1 is 4x plus y is equal to 6. So for the value of x is 1, we're going to substitute 4 times 1 plus y is equal to 6. Then 4 times 1 is 4 plus y is equal to 6. So we're going to transpose this 4 to the other side. So we have y is equal to 6 minus 4. Then y is equal to 6 minus 4 is 2. So we have the value of x and y. So we're going to conclude, therefore, the solution set is one and 2. And the system is, what is the system? The system is consistent, independent, because it only has a one solution. The system is consistent, independent. So that's the process on how to add a two variables or equations rather using the elimination method. So now let us proceed to substitution method. So let us use a same equations. So we have equation 1 for x plus y is equal to 6 and equation 2 is 2x minus 3y is equal to negative 4. So the first step that we're going to do is get the value of y of which equation? So we're going to use the equation 1. We're going to find the value of y of equation 1. So equation 1 is 4x plus y is equal to 6. So to get the value of y, we're going to transpose this 4x to the other side. So we have y is equal to 6 minus negative 4x. So now we have a value of y. So we're going to substitute this value of y to the second equation. So we have 2x minus 3y is equal to negative 4. Then we're going to substitute. So we have 2x minus 3 multiplied by the value of y, which is 6 minus 4x, is equal to negative 4. So let us simplify. We have 2x minus negative 3 times 6 is negative 18. Then negative 3 times negative 4x is positive 12x is equal to negative 4. So combine like terms, we have 2x plus 12x, we have 14x minus 18 is equal to negative 4. So we're going to transpose this constant so that we have only a variable of x here. So we have 14x is equal to negative 4 plus 18. So we have 14x is equal to 14. So to get the value of x, we're going to divide both sides to 14. So we can cancel this one. We have only x is equal to 14 divided by 14. We have 1. So the value of x is 1. So to get the value of y, we're going to substitute this value of x to the equations. So let us use the equation 1 again. So let x is equal to 1 to equation 1, or to this equation rather. So let's say this is equation 3. So let x is equal to 1 to equation 3 to find the value of y. So we have y is equal to 6 minus 4x. So y is equal to 6 minus 4. Then we're going to substitute the value of x, which is 1. So y is equal to 6 minus 4 times 1 is 4. So y is equal to 6 minus 4. We have 2. So the value of x is 1 and the value of y is 2. So let us conclude. Therefore, the solution set is 1 and 2, and the system is, we only have one solution again, so the system is consistent, independent. So that's the process on how to add two equations using a substitution method. So now let's proceed on how to solve a system with 3 variables using elimination method. So we have equations here. So the equation 1 is negative 3x minus 5y minus 2z is equal to negative 23. Then equation 2 is 6x minus y plus z is equal to negative 14. And equation 3 is negative 4x minus y minus 6z is equal to 10. So first, we're going to add equation 1 and equation 2 so that we can find the equation 4. So let's say we're going to eliminate the value of y. So we're going to multiply equation 2 to negative 5. So we have equation 1 plus negative 5 multiplied by equation 2. So equation 1 is 3x minus 5y minus 2z is equal to negative 23. And equation 2 multiplied by negative 5. So we have negative 5 multiplied by 6x is negative 30x. Then negative 5 multiplied by negative y is positive 5y. Then negative 5 multiplied by positive z is negative 5z. And negative 5 multiplied by negative 14 is positive 70. So in this case, we can eliminate the value of y because negative 5y plus 5y is 0. So we can cancel this. Negative 3x plus negative 30x is negative 33x. So negative 2z plus negative 5z is negative 7z. The negative 23 plus 70 is 47. So this equation is the equation 4. So we have equation 4, so we're going to find the equation 5 by adding equation 2 and equation 3. But in this case, we can multiply the equation 3 to negative 1 so that we can also eliminate the value of y. So we have equation 2 plus negative 1 multiplied by equation 3. So equation 2 is 6x minus y plus z is equal to negative 14. And equation 3 is multiplied by negative 1. So negative 1 times negative 4x is 4x. Negative 1 times negative y is positive y. Negative 1 times negative 6z is positive 6z is equal to negative 1 times 10 is negative 10. So we can eliminate the y because 7y plus y is 0. So cancel. 6x plus 4x is 10x. Z plus 6z is 7z. Then negative 14 plus negative 10 is negative 24. So this equation is the equation number 5. So now we have equation 4 and equation 5. We're going to use these equations to find the value of x or the value of z. In this case, we can now eliminate the value of z because negative 7x plus negative 7x is 0. So, we have equation 4 plus equation 5. Equation 4 is negative 33x minus 7z is equal to 47. And the equation 5 is 10x plus 7z is equal to negative 24. So we can cancel the value of z. So we have negative 33x plus 10x is negative 23x is equal to 47 plus negative 24 is 23. So we can find the value of x by dividing both sides by negative 23. So negative 23 x divided by negative 23 is x. 23 divided by negative 23 is negative 1. So now we have the value of x. Now we can substitute the value of x to equation 4 or to equation 5 to find the value of z. So let's use the equation 4. So let x is equal to negative 1 to equation 4 to find z. So equation 4 is negative 33x minus 7z is equal to 47. So negative 33 multiply the value of x, which is negative 1, minus 7z is equal to 47. So we have negative 33 multiplied by negative 1 is 33 minus 7z is equal to 47. Oh, this is 47 number. So we can transpose 33 to other side so that negative 7z is equal to 47 minus 33. So we have negative 7z is equal to 14. So divide both sides by negative 7. Negative 7. Negative 7z divided by negative 7 is z is equal to 14 divided by negative 7 is negative 2. So we have the value of x and z. So we're going to use the value of x and z to, let's say in equation 1, to find the value of y. So equation 1 is negative 3x minus 5y minus 2z is equal to negative 23. So negative 3 multiplied by the value of x, which is negative 1, minus 5y minus 2. The value of z is negative 2 is equal to 23. So we have negative 3 times negative 1 is 3 minus 5y minus negative 2 multiplied by negative 2 is positive 4 is equal to negative 23. So we have 5y is equal to negative 23. We're going to transpose. It may happen that this 3 is negative to this side and 4 becomes negative 4. So we have 5y is equal to negative 23 plus minus 3 minus 4 is negative 30. So we're going to divide both sides by 5. So 5y divided by 5 is y, and negative 30 divided by 5 is negative 6. So this is the value of y. So to conclude, therefore, the solution set is negative 1, negative 6, negative 2, and the system is consistent independent. So, independent rather. So that's the process on how to solve a system with 3 variables using elimination method. So at first we're going to get the equation 4, the equation 5, then we're going to use equation 4 and 5 to get a one variable. So substitute the one variable to equation 4 and 5 to get the other variable, and the 2 variables will now substitute to equation 1, 2, or 3 to get the last variable. So that's all.